Good evening, sir.
Good evening, sir.
Yeah, good evening.
Good evening, sir.
Okay, good evening, students. I'm start பண்ணலாம். Just share பண்றேன் my screen. I'll start sharing my screen. Okay, let me know if you're able to see the screen that is being shared. Word file தான் share பண்ண போறேன். Just let me know if you're able to see it, all of you. Time lag might be there, but you should be able to see it. Okay. Okay, screen visible இருக்குங்களா? I hope everybody is able to see the screen.
Yes, sir.
Yes?
Yes, sir, it's visible.
Okay, okay, great. Okay, so we'll start, children. Good evening again, once again to all of you. So we'll be, looking at a new chapter today. One chapter we have already covered, one chapter that is units and measurement. That is what we have covered, units and dimensions, in the last class. So now we are starting off with a brand new chapter, which is motion in a straight line. So that is what we will be looking at for today. Okay. So I'll just put the title here. The heading, chapter heading. I hope you're able to, all are able to see it, justify it.
Okay.
Okay. Right. So we look at broad concepts here. Certain concepts you would have already learned in grade 10 or 9, mostly 9th standard you would have learned. Okay, there are simple concepts, in this chapter, not too complicated. But as we go higher and higher, I will be introducing, certain mathematical, branches also, like differentiation and integration. So we'll be looking at that also, because the chapter demands that. So we will be looking at. So to begin with, we will look at all the basic concepts. One by one, we will have a quick, recap, I can say, because you guys have learned this. For some of you, it might be very familiar. So it's not going to be Greek and Latin. It's going to be simple. Don't worry. So we look at each one of the concepts. Let's have a quick summary and then get into different problems. Okay, that is what I have planned in for today. Okay, so basic definitions. Motion, I think most of you know what is motion. An object is said to be in motion if it's going to change its position with time. Okay, so that is basic aspects. I'll leave it to you. So we'll look at the different terminologies, the concepts like displacement. Okay, I think you guys would have heard about this term, displacement. What is meant by displacement? Can anybody tell me in your own words? Displacement. What is meant by
So the
it?
shortest distance from like to travel from one place to other.
Yes, displacement is basically a shortest distance between initial and final point of an object during its entire journey. Okay, that is called as displacement. I'll give you the basic definition here. Let's say it is defined as the shortest distance between initial and final point of an object during its journey. That is, this is basically displacement. I can hear a lot of background noise. I think it is Keshamurthy sir. One second. Can you hear him, all of you? I think he is audible, right? Or a vector quantity?
Vector.
Vector quantity.
Yes, it is a vector quantity because it has both magnitude and direction. Okay. So I'll just mention here it is a vector quantity. Okay. So this is the basic idea of displacement. Now coming to the formula of displacement, it's got a simple formula also. So this is the formula. It is represented using delta x. Okay. So where delta x is change, in the position, that is initial final position minus initial position, we can write. I'll write this like this as xf minus xi. Okay, so change in position will give you that corresponding displacement of an object. And what is the SI unit? The SI unit is meters.
Meters.
Good. That's all about the displacement. Basic idea we have. Next is velocity. What is velocity? Anybody? Yes. Velocity is defined as the rate of change of
displacement.
Yes, the rate of change of position or displacement of an object with time. That's called velocity. Very good. It is the rate of change of position or displacement with time. That's it, and that is the basic definition of velocity. And the formula for velocity can be
Delta D by
expressed.
T.
Yes, v is equal to, we can say, x upon t, displacement upon time, or delta x upon delta t. That's also fine. So you can express it like that. So this is this formula, and the unit is meters per second. That's the unit for velocity. Simple. And velocity is also a vector quantity that you guys know it. Okay. Next we have speed. What is the definition for speed and the formula for speed? Let's have a quick, run through.
Magnitude of velocity is called speed.
Speed. Okay. Speed is basically, as you said, magnitude of velocity. That's absolutely right. You can also call it the ratio of distance traveled to the time taken of an object. Okay, in simple terms. So we will write speed as s is equal to. I'll give you the formula directly because definitions, mostly they don't ask anywhere. So we'll just dump into the formulas. Speed s is equal to, we can say, v upon t, which is distance traveled upon time taken. And what about the SI unit for speed?
Meter per second.
Very good, it's meters per second. And then we move on to acceleration. What's acceleration, by the way?
Change in velocity by time.
Yes, it can be defined as the rate of change of velocity. And what would be the formula? We'll see each one of them. Here you need to know the representation of certain uh, physical quantities, how we represent in kinematic equations, and what are their names. E is called what, U is called what, all that you need to be knowing. I hope you guys know it. V is nothing but
Yes,
final
sir.
velocity. E is final velocity, and what about U?
Initial velocity.
U is initial velocity, and A,
Acceleration.
okay, and S,
Displacement.
okay, and T is,
Time.
okay. This is displacement. And finally, T is nothing but time. Now we are going to see the equations one by one. The first kinematic equation, how do we express it? Okay.
V is equal to U plus RT.
Yeah, V is equal to U plus AP. You rearrange acceleration formula, you will arrive at this kinematic equation. This is the first kinematic equation. It relates velocity and time relationship. Okay. Second kinematic equation,
S is equal to UT plus half AT square.
that's correct. S is equal to UT half at squared. Again, this is the second kinematic equation, and the third one,
V square minus G square equal to A.
v squared equals u squared plus 2as. I have this rearranged and written. So these are all the kinematic equations that you will have to remember. It's very important to note that first two kinematic equations are time dependent, wherein the third kinematic equation is time independent, which means there is no time term for the third one. Okay. So in cases where in certain questions where time is not specified, but velocity and acceleration and the displacements are being specified, you would appropriately use the third kinematic equations. Okay. So you have to make a wise choice of what equation to be used under what circumstance based on the given data. So that's what you guys should be aware of. All right, and then moving on to the next concept. Next concept is nothing but stopping distance. Very very important. Okay, I don't know if you guys have heard this before. If you know the formula, you can tell me what is the optimum stopping distance for a vehicle. So we give it as it's represented using ds, optimal stopping distance. Okay, so ds is equal to minus u upon 2a.
So what is the stopping distance?
Okay, this is a stopping distance. Yeah, I'll tell you. Now, stopping distance is basically whenever a vehicle is accelerating and it has to stop after it travels a certain distance. Then, if the body is going to travel an equal distance in equal interval of time along the straight line, it's uniform, and we find out what is the distance at which the vehicle can stop. So we can find that using this formula directly. This is called as the stopping distance of a vehicle. Okay, so you need to just remember this formula for applying it directly. Otherwise, you can even derive it also. It's not a big deal. But to save time, we will use this directly.
So shouldn't we use final velocity instead of initial velocity?
Initial velocity, because the object has started, it is having some initial velocity, and stopping distance, final velocity becomes zero, right? Because you're going to stop it. So initial velocity is not zero, but final velocity becomes zero. So that's the reason that term is not here. Okay.
Yes.
Yeah, I hope that makes sense. So now moving on. Next we have something called as average speed. I think you guys know what is average speed. The formula for average speed, rather. Any idea? Nothing but total displacement. That is average velocity, what you're saying. This is average speed. So total distance traveled.
Total path length divided by total time interval.
Yes. Total distance traveled by the total time taken. Or the total path length upon total time taken. Both are one and the same. So this is the average speed formula. Again, the unit is same, which is meter per second. There is no change in the unit, and it is again a scalar quantity. Average velocity. That formula also we would see. Average velocity is given by the formula total displacement or net displacement upon total time. So that's
Sir, your screen is not visible, sir.
I'm sharing the screen, you must be able to see it. So
Yes, visible, sir.
I think it is visible because it says that I am presenting, and you should be able to see it, because otherwise you just try to rejoin. In case you guys are not able to see it, the person who just spoke, you can try to rejoin. Okay, the problem will be solved. Fine. So this is all about average velocity. So we have looked at the formulas for average speed. Now average velocity, stopping distance is also done. Moving on to the next one, the next formula. Now we have instantaneous velocity. Instantaneous velocity formula. we can express this as a derivative term. Okay, instantaneous velocity. So, can anybody tell me what would be the formula for instantaneous velocity? You can say dx or ds upon dt. So this is instantaneous velocity. Same way you can also represent instantaneous acceleration. These formulas, please make a note because it's quite important. Then you have instantaneous acceleration. So it is dv upon dt. Rate of change of velocity with time. So again, I'm giving a differential term here. So d by dt times v. Okay. So this is instantaneous acceleration. These are certain formulas that you guys should keep in mind. After that, we have relative velocity. Very, very important. What is meant by relative velocity? We'll see this also. So suppose if I say the velocity of an object A relative to object B. I repeat, velocity of object A relative to B is expressed as VAB. Okay? I'll just give you here. Velocity of object A relative to B by VAB. That is expressed as EA minus B. It's quite important. You should make a note of this. This is the relative velocity concept. Velocity of an object with respect to the other. That's what we are looking at. Okay? So we can write it like this.
Sir, please tell me an example, sir.
Yes, we'll be looking at examples also. Okay. Yeah. We are going to solve problems, don't worry. Okay, we are definitely going to look at examples.
Not a problem, sir. A live example.
Okay, fine. Live example is, for instance, if I say a man is traveling. Let me put it here. Example for 11. Example question. Okay. A train is traveling at the rate of say 60 kilometers per hour towards east. Okay. Train is traveling at the rate of 60 kilometers towards east. A man on the neighboring train or instead of putting on, I'll put it like this. A man inside the neighboring train, traveling at the rate of 80 kilometers per hour in the opposite direction. Okay. Now the question is, determine the relative velocity of the man with respect to the train. Okay, this is a question which I framed now. I have a train traveling at the rate of 60 kilometers per hour towards east. and there is a man sitting inside the neighboring train. I'll put it there. I didn't put a train there. Sorry, neighboring train traveling at the rate of 80 kilometers per hour in the opposite direction. Okay. The question is, you should determine the relative velocity of the man with respect to the train. So here you have two cases. One is you have a train that is traveling towards east. Towards east in the sense, now if you are going to represent this on a piece of paper, you would draw an arrow mark facing the right side. Isn't it? Okay, so that's how you show. Same way, how would you represent the man traveling in the other train? Again, you can represent that using an arrow mark facing the left side.
Right, sir.
Okay. Now the question is, you should find out the relative velocity of the man with respect to the train. So how do we represent this? How do you go for representing? So we write it as V M T, where M represents man and T represents train. Simple. Okay. This is how we can represent the relative velocity, V M T, where M represents man, T represents train. So when you read this term, you will read it as relative velocity of the man with respect to the train. That is how you read. Okay. Now you can see that both of them are traveling in the opposite directions. Okay. So they are going to travel in the corresponding opposite directions. Now obviously, you are going to apply the concept of the velocities. Now individual velocities you are applying, and then you are going to solve this question. So anybody can try this, and what is the answer that you're getting? Can you tell me? Simple. Because I've given you the formula. So what answer would you get?
$20 kilometers per hour.
Yes. 20 kilometers per hour. Okay, how did you get that?
Sir, is it not minus 20?
Okay, one of you are telling minus 20. Okay.
Minus 20.
Minus 20. Okay, how is it minus 20? Yes. So how did you get minus 20? Can you just tell me? What did you guys do?
Traveling out there.
Oh, I'm not able to hear, dear. I think there is some
Sir, VT minus VM, sir.
VT minus VM. Okay. So, why are you telling VT minus VM, not VM minus VT?
Opposite direction, sir. So
Correct.
it must be minus.
So both are in opposite directions. It has to be negative, is it? Okay. See, now here what we do, whenever you have two objects moving in the opposite directions. Okay, so you will have to, here directions, play a very important role. Whenever you have objects traveling in the same direction, you will go for a subtraction. Okay, now appropriately you would subtract the bigger velocity from the smaller velocity. That is what you do. This is one important rule that you guys should keep it in mind. When two objects are traveling in the same direction, and they are asking you relate the velocity of one object with respect to the other object, what you do appropriately is you would go for a subtraction based on, because I am talking about velocity and I am not talking about speed. But the speed, it is different because we are dealing with velocity. So therefore what we do appropriately, we are going to do a subtraction. One object is moving, the other object is also moving in the opposite of direction of motion of the first object. In that case, you go for a subtraction. So you will have to please keep this in mind. So what you are going to do here is, say the train is moving towards the right. That is, east means it is right direction. So according to Cartesian coordinate system, you know that is going to be towards the right. So obviously that's going to be positive. Okay. So that is there. Fine. So when I go to express this, so I will write this as Vm. First I'll show you. So we first write as Vm, and your train, the man on the train is traveling in the opposite direction. So and you have train also traveling in one corresponding direction. So that is something that you have to keep in mind. So I would take here negative sign convention because the man on the other train is approaching from the other direction. That is moving on the left side. So left side means it is negative x-axis. According to Cartesian coordinate system, you would take minus sign, very very important. Then I would write minus. So now here basically not minus sign because they are moving in the opposite directions. So appropriately I would write Vm minus Vm plus Vt. I'm taking capital T, I'm putting capital. Because that is traveling towards the right. Train is traveling towards the right. So this is how you are going to update. Then you go to substitute the values. Substituting the values for the man on the other train, which is given as 80. So I am writing minus 80 kilometers per hour. Okay, I'm just writing the numbers here, and plus 60. Minus 80 plus 60 would give you minus 20 kilometers per hour. So this is how you solve questions based on the given scenario. You directly apply and then you solve it. This is the approach. Okay, I hope it is clear. Based on the direction of motion of the objects, you have to calculate the relative velocity given the situation. So this is how we do it. I hope it's clear. Somebody asked for an example, so I've done it. Fine. Yeah. So now we are moving on. So this is all the concepts that you need to be knowing. I've given you all the basic inputs. Now we will be solving, different questions based on this. So let's see the questions, different model questions. Okay. Are you guys well versed with derivatives, differentiation? The basic formula for differentiation, everybody knows? Okay, what is d by differentiation of x power n, the basic formula? D by dx
Sir,
of x power n.
n x to the power n minus 1.
nx to the power n minus 1.
Yeah. Nx to the power n minus 1. This is the basic formula. So just have this in mind. Okay, because in certain cases when we have differentials, you will have to be able to apply this. Same way, even the integration also. For integration, basic integral formula, just have a note. So what is integration of x to the power n dx?
X power n plus 1 divided by n plus 1.
Yeah. So that is equal to x to the power of n plus 1 on n plus 1. That's it. This is the basic formulas for differentiation and integration. So I wanted you guys to know this also. In certain questions, it's necessary that you are going to apply these concepts. Okay. So now we look at each one of the questions one by one. Okay. We'll start with easier ones and then appropriately we will move on to difficult questions. So here we go. First question. Practice questions we are going to see. Here comes the first practice question. Now, the person